Hello and welcome to our next Java session. Today's topic is data types and operators. So let's begin. Now what are data? Data is can be of any form, like it could be of type number, it could be of type image or a video or an audio. So for every data we need it to be stored somewhere in a memory location. So for every data which we store, there is a data type associated with it. Okay, so in Java there are two types of data, like primitive data types and non-primitive data types. Now primitive data types are the data types which is of type byte, short, int, long, float, double, boolean, character. Okay, which stores values of any of these forms. It could be a number, it could be a decimal, it could be a character. And non-primitive data types are nothing but these data types are already been defined in our Java library. Okay, these are nothing but the classes. And what are classes? Classes is collection of properties and methods. So these are predefined data types which we are going to use where we require them. For example, we have started using system. System is a non-primitive data type, and system.out.println. So println is a method. So these non-primitive data types are already declared, but the primitive data types is as and when we need it, we are going to declare it and use it. Now every data type whichever you are going to use will occupy some memory. Okay, some memory space will be there, so there will be a size associated with it, and there is a description with it. Okay, for example, a byte will take 1 byte of data and it stores numbers between -128 to 127. So if you need a smaller number to get stored, so instead of declaring a data type of type say int, which is occupies 4 bytes of memory space, you can use byte. When we know the range, like I know that I'll be storing either 0 and 1, so why to declare a variable which will be of type int? There I can use a variable of type byte. That will it will help us to save the memory as well as we know the range of it. Similarly, we have short, which is 2 bytes, which takes -32,768 to 32,767. Int, which takes 4 bytes, it takes a very big number. Long, it takes 8 bytes. Float, it takes your decimal numbers like 2.14, and it allows decimals to 6 to 7 decimal digits. That is, after your dot you can have 6 to 7 numbers. Double, again it takes 8 bytes, which has it where we can store the decimal digits up to 15. Boolean, it takes 1 bit, which stores value true or false. And character, it takes 2 bytes, which stores the characters like your alphabets, capital A to capital Z, small a to small z, and your special symbols which you can see on your keyboard, that is exclamation, at the rate, hash, dollar. These are again the special symbols. So for every character there is an ASCII value associated with it. For example, capital A to Z, the ASCII value is 65 to 90. It's a number. And small a to small z, the ASCII value is 97 to 122. Now these are the ways we can declare the variables. The data type, the variable name equal to the value. Or you can just have data type, the variable name, and if you don't want to initialize the value, put just a semicolon. So these are the different types of data types we saw just now, and here you can see how the values are assigned to it. If it is a float, then we have to mention f after every value, and if it is a long, you have to mention l, otherwise it will give us an error. Now, as I told you, non-primitive data types are nothing but the classes. Okay, so these are called reference types. These are also called reference type because they refer to objects. Okay, now there are few differences between primitive and non-primitive. Now, non-primitive types are predefined, already defined in Java. Primitive types are created by the programmer and is not defined by Java. Okay, so that is we declare the variables as and when we need it, but non-primitive, the variables are already been declared over there. Non-primitive types can be used to call methods to perform certain operations, while primitive types cannot. Now, as I told you, non-primitives are nothing but the class names, and class is nothing but collection of properties and methods. So with the help of the non-primitive class name, we can call the methods, like how we did system.out.println. So the primitive non-primitive data type was system, and I called the method println. So it is used to call methods to perform certain operations. A primitive type has always a value, that is, always a value is stored in a primitive, but a non-primitive type can be null. Now when we will start with classes, that time I will explain you what is a class and what do you mean by object and how the memory is allocated for an object, and in that time we will come across this name, that is null. A primitive type starts with lowercase while non-primitive type starts with an uppercase. So the non-primitive data types are always coming in an uppercase, like how you can see here: strings, arrays, classes, interfaces. These are nothing but the non-primitive data types. The size of primitive type depends on the data type, while non-primitive types have all the same size. Okay, now we have seen just now that there are sizes, there are different data types and different sizes are there. So every primitive data type has a size, okay, and which is defined. But a non-primitive types, they have all of the same size. Now there are different operators in Java. These are the ones which are listed: unary, arithmetic, relational, bitwise, logical, ternary, and assignment. Now we will see one by one the operators with an example. Now before we move ahead with the operators, what is the precedence of Java operators? Now for example, first I'll just tell you what do I mean by that. If you can recollect, in maths, like I say C is equal to A multiplied by B divided by D. So this is nothing but, this is called an expression. This is an expression. Okay. Now every value, whichever expression we are writing, we execute it from either left to right or from right to left. Okay. So what you can see over here is nothing but the associativity. That is how it is, how the expression is getting executed. Is it getting left to right, or it is right to left? Okay. So first we will see the unary operators. These are nothing but plus and minus, and you are having negation and a complement also. Okay, so these are the unary operators. Then you are having the multiplication operators, where we use multiplication, division, and then we are using the mod operator. Then you have got addition, plus and minus are there. Then relational are there, equality is there, and all these are there. We will first go one by one. First we will see the unary operator example. Okay, now I'll just open one example of unary operator. Now this is already an example being created. I'll just save this somewhere else. Fine. So now this is a class. This is the class name. Then we know that every class, where it should have a public static void main. So here is a public static void main, and this is a data type X, which is of type int, and a value assigned to it is 10. Okay. Now if I use another data type, say Y, and I say Y equal to X plus plus. Okay. So now when I'm using plus plus after the data type, or sorry, after the variable name, then this is postfix. So this is what? Postfix. And if you're using it before, then, like for example, if I do plus plus X, then this is prefix. Okay. Now if I just use X plus plus. Okay. So X plus plus I have done. So what does this thing mean is, I am going to increment the value of X plus 1. Fine. So X plus plus is nothing but I'm incrementing the value of X by 1. So X value will be 11. So the value of X is getting changed over here. So if you are using it in this way, then it is like even if you do X plus plus, or you do plus plus X, both the output will be the same only. Okay. x will be always 11. But if you're trying to use it in an expression, now this is an expression. Why? Because we are putting y equal to and then something. So at that time the definition of these postfix and prefix operators change. Okay, so that time they behave differently. Now how do they behave? Over here what will happen is the value of x will get assigned to y and then x value will get incremented. So here y will be having value as 10 and then x value will get incremented to 11. Okay, so just we will first what we'll do, we will print the value of x over here. System.out.println, I am printing the value of x. Okay, so what was there in x? 10. So plus plus x is nothing but x will be 11. So when I come here, x value is 11. So y will be assigned the value of x, that is 11, and then x value will be incremented to 1. So now if I print the value of y over here and x, both I will print. Okay, now we will just see what will be the output. Now I am going in my folder where I have saved these Java programs, and here I am executing the file with the help of Java C. So now we have to just observe the output, how it is coming. See, first it is plus plus x, so y, x's value is getting incremented by 1. So here x I am printing, first line you can see the output is 11. Now y equal to x plus plus. Now as I told you, when it is a postfix and it is in an expression, then the value of x will get assigned to y first and then it will get incremented. So y will be what? 11 and then x value is getting incremented. So here you can see the value of x is 12. Okay, so supposing if I do it in this way, now I do it in plus plus x. So now this is prefix. So when it is prefix, then the value of x also first gets incremented and then it gets assigned to y. So here it was 11. So its first x value will get incremented by 1. So that is 12 and then it will get assigned to y. So here x and y both output will be 12. Just a minute. Yeah, I didn't compile it properly. So here you can see the x value is also 12 and y's value is also 12. Just for your understanding, I'll do y a colon mark and I want to print the value of the variable. Now if you want to print the value of any variable with a string, now you can see anything put in double quotes is called treated as string, and I'll put a plus sign. So plus sign is concatenating the string with the variable value. So it will be y equal colon and the value of y. Similarly x, so the output we will more readable, we are making it. Okay, and the value of x, similarly I'll do this over here and I put plus. So plus is basically concatenating a string and the value of a variable. If you're printing the value of a variable, you're not supposed to put it in double quotes, then it will be treated as string. So you should always, whenever you're printing the value of a variable, just the variable name we have to mention. So here you can see x is 11, y is 12, x is 12. Now if I again, I'll just make it postfix. Whenever you save the program, make changes, you have to save and again compile it. Otherwise you'll get the previous output only. So here you can see x is 11, y is 11 and x is 12, because here it is postfix. So it is first assigning the value to y and then incrementing. If it is prefix, it will increment and then assign. So there is a difference between this postfix and prefix when you are using in an expression. So we'll move ahead. We'll see one more example. Okay. Now this is in system.out.println. I'm using this. Okay. So now what it is happening? A plus plus. So it is postfix. Okay. This is similar to an expression. Okay. That is, for example, I say int c equal to, I'll just put it here. And here I'll just print the value of c. Fine. So now what is this? C equal to a plus plus. Now a's value is 10, b's value is 10. Fine. So a is a plus plus, that is, it is postfix. So it will first return the value of a. So what is the value of a? It is 10. Okay. Now here it is a plus. So this particular expression is going to get executed from left to right. This will go from left to right. So this is 10 plus, then this is plus plus a, means what? Now this got increment 10, it is printing, and a got incremented to 1. So that is a's value is 11. So when you come here, a's value is 11. Fine. So this will get incremented again by 1, that is 12, and then that value will get returned here. So this will be 12. Again I'll tell you, a plus plus, we know when it is plus plus, after postfix it will return the value and then increment it by 1. So here a's value is returned, say 10, and then a got incremented by 1, that is 11. Then I wrote a plus sign, then plus plus a. So when it is plus plus a, it will first increment and then return the value. So this is a's, as it was 11 over here, this became 12, and then it will return. So if I print the value of c, the output will be 22. Okay. Now over here, similarly, now just see what is done here. Both are postfix. So this is what b is 10. So it will return 10. Fine. And incrementing the value of b by 1, that is 11. So this is 10 comes here, plus. Now again it is postfix, so it will return 11 and then increment it by 1. So this will return 11. And the output of this will be 21. So you might get an examples like this for predict the output. So we will just see this. I've got an error. Let's see what it is saying. Error over here. Fine. Here I haven't started the class. You can see it was giving an expected curly braces. Now I'll execute this. So here you can see as how we had expected, we got the output. The first answer is 22 and the next answer is 21. So you can try out all these examples. I'll be sharing you these programs in the folder where I'm uploading these files. So if you want to use these programs, you just need to download those programs and save it on your machine. Now let's move ahead with the next topic, that is the arithmetic operators. Now we all know what are these plus, minus, multiplication. Only the difference over here is when we do division and mod. So when I am doing division, that time this 10 is divided by 5. Okay, so it returns the quotient, and when I'm doing mod, it only divides but it returns the remainder. So here the outputs are mentioned. Here the output will be 15, 5, 50. Here the quotient will be 2, 10 divided by 5, and 10 divided by 5 the remainder. So mod operator, this is a mod operator, we call it as mod operator. It returns the quotient. Okay, so Java C arithmetic operations. So as per this thing, we are getting the output. Now we'll see an example of precedence. Now what do you mean by precedence? Now here you can see this is an expression. Fine. And this expression is put in the system.out.println. Now if you go back over here, these are our operators. Okay, now you can see the precedence over here. This is lowest, and as we move ahead on the top it is highest. So here multiplication, division and mod is having more precedence than addition and subtraction. So if in an expression, if you know BODMAS rule, that is bracket of division, multiplication, addition and subtraction, so the same rule we are going to use it over here. So if it is, there is a multiplication and division, then first, and there is plus and minus, then it will execute from left to right, and depending if it is multiplication is coming first, multiplication will happen first. If division is coming, division. And if it is plus and multiplication together, then first multiplication will happen and then the addition will happen. So we will see this example. Now here you can see the expression is written in this way. So let me first copy this expression. It is 10 multiplied by 10 divided by 5 plus 3 minus 1 multiplied by 4 and divided by 2. Okay, so this is our expression. So we know that multiplication and division is having the same precedence, and plus and minus is also having the same precedence. So, and if it is like now we have got all together, then first we will go from left to right. So this is 10 multiplied by 10, so it will be 100 divided by 5, then plus 3 minus 1 multiplied by 4 and divided by 2. Fine. So again now you have got division, plus, minus, multiplication, and then again a division. So now again we are going in this direction, left to right. So it is 100 divided by 5. So it will be 20. So it will be 20 plus 3 minus 1 multiplied by 4 and divided by 2. Now we are having plus, minus, then multiplication. So again this is multiplication will happen first and then the division, because again we are following this left to right. So it will be 20 plus 3 minus 1 multiplied by 4, that is minus 4 divided by 2. So now over here it is first, now it is plus, minus, 4, division. So now the division will happen. So it is 20 plus 3 minus 2. Fine. So now this is plus and minus, both are having the same precedence. So it will go from left to right. So this is 23 minus 2, that is equal to 21. So this expression, the output should come as 21. Okay, we just first see the output of this. And then, so you can see the output we got it as 21. Okay, so it is left to right. If both are operators having the same precedence, then the first operator which you find, that gets executed, and then the next one. But if I put a bracket, okay, now here same expression I'm using, but I have put a bracket. So whatever is there in the bracket, that is always having the highest precedence. Okay, so now the same example, I'm doing it, but I have put a bracket now. Now let's first copy that expression. So what is the expression? 10 multiplied by a bracket 10 divided by again a bracket 5 plus 3 bracket complete, the outer bracket complete, minus 1 multiplied by 4 divided by 2. Now it's the same expression, but now we have put it in a bracket. So now what will happen? First, you can see there is an outer bracket. This is the outer bracket and this is the inner bracket. Okay, so here first the inner bracket is getting will get executed. So 5 plus 3. Now there is a division, but as whatever is in the bracket has got a highest precedence, so first the inner bracket will get executed. So it will be what? 10 multiplied by the outer bracket 10 divided by, now what is the output of 5 plus 3? 8. Okay, then the outer bracket minus 1 multiplied by 4 divided by 2. Now we know that if it is a division, then it returns the quotient. So now this is a simple 10 upon 8. How you divide? So it is 2 5s are 10, 2 4s are 8. Okay, and 5 divided by 4 is, it's a decimal actually. So it is what? 1 point something. Okay, so it will return what? 1. So this is 10 divided by 8 will return what? 1. So here it is 10 multiplied by 1 because it is returning the quotient, then minus 1 multiplied by 4 divided by 2. So now again we have encountered a multiplication sign and a division sign. So first the multiplication will happen. So it will be 10 minus 1 multiplied by 4 divided by 2, and then 10. Now this is minus multiplication. So now again here the multiplication is happening first. Minus 4 divided by 2. So now 4 divided by 2, it is 2. So it is 10 minus 2 and the output is 8. So we should get the output as what? 8 over here. Here in Y I should get the output as 8. Here you can see the output has come as 8. So these whenever you are using these operators, the output will depend on how is the expression. Okay, so we know that your multiplication and division and mod are having the same precedence, and then the addition and subtraction. So this thing you have to keep in mind. So depending on their precedence, the expression is going to get solved. So this was a precedence example. Now the relational operators. Now relational operators are what? It's a comparison type of operators which will return either true or false. So the relational operators are equal to, which is comparison. That is, example is A multiplied by B. A is equal to B. So this is comparing to. Okay. If it is simple A equal to B, then it is assigning, like how we just now said. A equal to 10, B equal to 20. So this is an assignment. That is, a value 10 is getting assigned. But if you want to compare, then it is double equal to. So you have got less than, it compares and returns Boolean value, less than equal to, greater than equal to, not equal to. So we will see these when we will do if statements. In that we will use all these relational operators the way we need it. Then you are having a bitwise operator. Okay, now bitwise operator is nothing but it works on the operand and it gives us a value. Now this operator is a binary operator, denoted by a single vertical line. This is OR. It returns bit by bit OR of input values. That is, if either of the bits is 1, it gives 1, else it gives 0. Okay, now it is like how, we'll just see an example. Supposing this is I'm talking about OR. Okay, so it is like 0 is false and 1 is true. So if it is both the conditions are true, then only any one condition is true, the output is true. Okay, so just a minute. Supposing I write here true, true, the output is true. True, false, the output is true. False, true, the output is true. Only when both the conditions are false, the output is false. So any one condition is true over here, the output is true. Okay, that is an OR. This operator, that is, if corresponding bits are different, it gives 1, else it gives 0. Okay, that is if you talk in bitwise. Okay, so both the conditions are true, the output is true. Both the conditions are false, then the output will become false. Any one condition is true, the output is true over here. And what happens in AND? It is opposite to, AND is nothing but it is opposite to AND, OR. That is, in this both the conditions should be true. If both bits are 1, it gives us 1, else it gives us 0. That is, over here both the conditions should be true. That is, if I write an AND, if both the conditions are true, the output will be true. If any one condition is false, the output will be false. So in AND we have to have both the conditions as true. Okay. So here, for example, if 0 and 1. Okay. So here 0 is true. 1 is true and 0 is false. So here if it is 1, 1, then output is 1. 0, 1, output is 0. 1, 0, output is 0. and 0 0, output is 0. So this is an AND. Okay, and what will be an OR? Here it will be what? Instead of TT, over here I'll say 1 1, output is 1, 0, sorry 1 0, output is 1, 0 1, output is 1, and 0 0, output is 0. So in OR, any one you get 1, the output is 1. So it is 1 1 1, 1 0 1, 0 1 1, and 0 0. If both are 0, then you get the output as 0. And in AND, both should be the true. Both the conditions should be true. Then only the output will be true. So this you have to keep in mind when we are using the logical operators. Now XOR is what? This operator is a binary operator denoted by this caret sign. It returns bit by bit XOR of input values. That is, if corresponding bits are different, it gives 1, else it gives 0. So what it is saying, if both the corresponding bits, like if it is 0 0, so it is like, we will just see this. I'll clean this. Now XOR. So we know true is 1 and false is 0. Okay, so now we'll just write first 1 0 0 1 1 1 and 0 0. Okay, so what does an XOR do? If corresponding bits are different, it gives 1s, else it gives 0. So corresponding bits are these two. If they are different, then it gives 1. And if both are same, it will give what? 0. So in this way the XOR is going to work. Corresponding bits are different, output is 1, and if it is same, the output is 0. Okay, and complement is what? It returns the 1 complement, that it gives the reverse, that is a 0 will become 1 and an 1 will become 0. Okay, in this way it works. Now we will see one example with it. Okay, now these operators and or, these are works on bits. Okay, now what is a bit? Now here you can see I have a variable a having value 5 and b as 7. Now every number is having a bit value associated it, which is in the form of zeros and ones. And how do we get that value? We find the 2's complement, that is we divide that value by 2. Okay, now that is, for example, here in my program 5 is there and 7 is there. Okay, so 5 is nothing but 0 1 0 1 and 7 is represented at 0 1 1 1. This is the way it is represented in the machine. Okay, you can say it's a machine, it's a bit representation of our number. It's a bit representation of the number. Okay, so now how did you get this value? No? So if it is 5, okay, what you have to do is you have to divide that number by 2. So 2 2s are 4, the remainder I'll write it over here. 2 1s are 2, the remainder I'll write it over here 0, and 2 zeros are the remainder I'm writing here. Okay, so this is nothing but I'm getting the one, you have to go from bottom to top. Okay, so this I'll write in which way? 1 0 1. Okay, so here you can see it is giving 1 0 1. Now they are making it as a 4-bit number. Okay, so for 4-bit number they are putting 0 before it. So here they have put 0 before it. Okay, now just to check whether our value is right or wrong, what I'll do is I'll just cross check it. Okay, so how do you do that? You have to find what is the number 0 1 0 1. So now this is nothing but the 2's complement, that is, this is the I start from here, it is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and likewise it will go. Now any number raised to 0, a raised to 0 is nothing but what? 1. Any number raised to 0 is 1. So this is 1. So 1 into 1, 1. So just write 1 over here. Now 2 raised to 1, that is 2, you have to multiply 1 time, that is 2, and multiplied by 0, it is 0. 2 raised to 2, that is 2 multiplied by 2, that is 4, multiplied by 1, it is 4. 2 raised to 3 is 6, 6 multiplied by 0 is again 0. And if you add this number, we get 5. So 0 1 0 1 is nothing but the right answer which we have got, because the addition is 5. So in this way we found out the complement of the binary number of 5. Likewise the binary number of 7 is 0 1 1 1. Now when I say A and B, okay, that thing means what? Now I'll just clean this. So what was it was what? 0 1 1, sorry, 0 1 0 1, and the next number was what? 0 1 1 1. Now we know that we are using an AND over here. So AND is what? When both the conditions are true, then the output is true. Any one condition is false, the output is false. So here 1 1, I get 1. This I am getting 0, and 1 1, again a 1, and then 0. Okay. So this is the binary output which I got of this number A and B. Okay. So now if you want to find out, when now I am printing here system.out.println A and B, so I have to find the value of this. So the previous way how we did it, that we are going to do 2 raised to 0, 2 raised to 1, you have to go from right to left, 2 raised to 2, and 2 raised to 3. So this is what? 1 plus 0 plus 4 plus 0, that is 5. So we just check whether the output we are getting over here as 5 or not. Okay, so we will just execute this program first. What's the program's name? Operators. Okay, the spelling is wrong. So you can see A and B, the output has come as 5. So similarly A or B, the output will be 7. Now it will, again we are going to use the same logic what we had learned just now, and accordingly we will find the answer. Okay, so it will be what? In A or B, what? Any one condition is true, output is true. So this is what? 0 0. So the output is 0 because both are false. This is 1 0 1 1. So output is 1. 0 1. So output we got 1, and 1 1 7. Oh sorry, 1. And when we whatever answer which we get 0 1 1, if you solve it we get the value as 7. And similarly the XOR is done and the bitwise AND is done. Okay. Now the logical AND is the same way, but over here it works on conditions. Okay. This operator returns true when both the conditions under the consideration are satisfied or are true. If any one of the two yields false, the operator results false. So here there are condition 1 and condition 2. So if A is 10 and B is 20 and C is say 20, and condition 1 is A less than B and condition 2 B equal to C. So here both the conditions are will be checked. That is, if A is less than B, 10 is less than 20, no. Okay. And B is equal to C, yes. So if both the conditions are true, then only it will execute whatever set of instructions we are going to write. Okay. So this is when we will do if. That time we are going to use these logical operators. In logical or is again conditions. If any one condition is true, the output is true. Okay. In the previous one, both the conditions should be true. Then only the output will be true. Here any one condition is true, the output will be true. And the not is nothing but it returns the opposite of the condition. So if the condition is returning true, it will make it as false, and if it is returning false, it will make it as true. So here the condition is there. So if A is less than B, is 10 less than 20 true. So negate yani it will give the opposite of it. So it will return false and this will return true. Okay. Now the next is the ternary operator. Now ternary operators are used instead of if. Okay, like in if we give a condition, if condition true then what and false then what. So the same thing you can put it in a ternary operator. Like I give an expression. Okay, this is my expression, this is my condition. Okay, if it is true then this, and if it is false then this, and whatever is the result that will be assigned to this variable. Okay, again I'll explain the condition. Okay, and a question mark and an expression colon expression. So if this condition will be evaluated first, if it is true then the first expression 2 will get returned and value will get assigned, and if it is false then this will get executed and the variable value will be assigned. Okay, so we'll see one example. Okay, now here it is variable n1 and n2 and max. So first I'm just printing n1's value and n2's value. So now I want to find the largest between these two numbers. So what am I giving? This is my condition. So if n1 is greater than n2, that is 5 is greater than 10. If it is true then it will return 5 or it will return 10. So the max value will be what? Over here 10. So here the first is the condition, a question mark, then the value which has to be returned and that will get assigned to max, colon, and if the condition is false then that value will get assigned to max. So here you can see first 5 and 10 I have got printed and now it is returning the maximum value. So in this way we can use the ternary operator. Now here same thing is used, but instead of returning a value some expression has been done. Like if n1 is greater than n2 then we are adding the numbers and then returning the output, or if it is less then we are subtracting the numbers and then returning the value. So something like that, a small expression also can be performed in this way. So here you can see 5 is not greater than 2. So n1, that is 5 minus 10, that is minus 5 is getting returned, and here you can see the result is minus 5. Now the assignment operators. I hope this is our last topic. Yeah. Now the assignment operators are nothing but the operators which will assign a value to a variable. Okay, it is nothing but an equal to. So here you can see a equal to 12, b equal to ch. So this is nothing but this value is getting assigned to the variable whichever is there to the left hand side of the equal to operator. Now the assignment operator can be used or we can use it in a shorthand form also, that is plus equal to. So here you can see num1 plus equal to num2 is nothing but num1 equal to num1 plus num2. Okay, so this is a shorthand notation. So a plus equal to 10 is nothing but a equal to a plus 10. A minus equal to 10 is a equal to a minus 10. So this plus equal to is can be used as a shorthand operator, and actually what is happening is over here the value a gets incremented by this variable value, and then it is getting assigned to the same variable name over here. Okay. So we have seen all the different types of operators. I would like you to just go through your textbook and check these operators. I will send you the examples also, whichever I have used in this particular video, and you can try this. If you have any queries, you can get back to me. Thank you.